I will record this. So this is the 4A worksheet, number 5, the evil suspended mastiff problem. The clues I'm going to give you are that, well, first of all, it's not a 30, 60, 90. You can't make it be a 30, 60, 90. It's not a 3, 4, 5. You can't just, it's not that easy. But because that is a triangle in there, we do know that theta 1 plus theta 2 have to equal 90 degrees. And that gives us a way to eliminate one variable. And force of tension 1, force of tension 2. We also know that, and I always do this randomly, I think they say force of tension, well, whichever one it is, one force of tension is 2 times the other one. Equals 2 times force of tension 2. And I don't care which is which. I'll figure that out later. So that gives us the ability to eliminate another variable. Oh, wait, no, actually, how do we do this? Okay, hold on. That gives us the ability to eliminate one of the force of tensions. Yeah, because then we can cancel out the force of tension on this in this problem. There's a way to do that. And then we start dealing with concepts like, well, if theta 1 plus theta 2 equals 90, then 90 minus theta 2 equals theta 1. And then we get into things like, you know, the sine of an angle minus something else equals the cosine of the other angle. We get into like, oh, that was it. What is it? The cosine of 90 minus one angle is equal to the sine of something else. I'm hinting all around this. I haven't done this yet this year, but I'm gonna, as I recall, you end up with like tan of theta, and then you can do some sort of magic and get one angle. And that's where I'm going to shut up. So because, I mean, and honestly, finding the angles is a great mental exercise. It's a good stumper. It's a good limber up your brain with trig and geometry. But it's not the most important thing to master in this problem. So you can go ahead and create, you know, get the final solution for what the force of tension in one of the cables is, and just have an equation that you're looking at going, well, if I had theta, now I could solve it. So you can go ahead and do that, and that all happens on the y-axis. And you can walk away from the x-axis for a little bit, and we'll fight with this a little bit more together. Because really, being able to solve for force of tension is more important. So if you want to step away from knowing what the angles are and go to the y-axis, create your expressions for, okay, I can see that force of tension 1 equals blah, 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 you know, sine theta 1, whatever. Okay, I got that much. You can do that, and that's something that's solvable right now.